Flight 03 has been canceled. We apologize for the inconvenience.
That might come as a shocker when you're sitting in the departure lounge looking at the gorgeous, bright, sunny weather outside. If there's not a rain cloud or snowstorm in sight, then what gives? Oh yeah, planes can't fly in extreme heat. In the summer of 2017, 50 flights were canceled, plus 7 that were only delayed, at Phoenix Sky Harbor International Airport. The reason? Temperatures were a brain-melting 120 degrees Fahrenheit. Truth be told, that crazy Arizona heat didn't affect larger planes like Boeing 747s or Airbus A320s, which can still take off even when it's 126 degrees out. Yet, in the age of super advanced technology, it seems weird that air travel can be interrupted by an unusually hot day. The reason why smaller jets like Bombardiers can't take the heat when it goes over 118 is actually in the nature of flight itself. Before every departure, pilots get detailed information on the air temperature, humidity, elevation, runway length, and other important things. The system processes this data to calculate optimum takeoff speed, thrust, and so on. However, it's impossible to calculate that data beyond certain limits. One of such limits is an extremely hot temperature. Now, to understand that, you need to know what makes planes fly in the first place. Spoiler alert, it's not magical fairy dust. It's the ability to generate enough lift. If there's no lift, a plane won't be able to take off and stay up in the air. So where does this lift come from? It all has to do with wings and how they're designed to redirect the movement of air. The wings collide with air particles and push them down. But those stubborn little air molecules resist that forced redirection and go right back up. Since the air particles are resisting that change, the pressure on the underside of the wing becomes higher. Over the top of the wing, the pressure remains low. This difference in pressure creates the lift, and it pushes the plane into the sky. For the plane to stay aloft, it's crucial that the pressure under the wing remains high. When the conditions are right, there should be no problem not only creating lift but also maintaining it. When something isn't right in that formula, a plane will hardly take off. You would think that heat or humidity is directly to blame here, but it's more about air density. The atmosphere gets thinner the higher up you go. Here, thinner simply means that the air molecules are further apart from each other. If you don't have as many air molecules pushing up on the wing, it becomes harder for the plane to generate enough lift. Now you can appreciate those engines that much more. They work hard to keep the plane in the air and you moving from A to B. Okay, so what about all this talk of planes can't fly in extreme heat? Well, hot weather has the same effect on air as higher altitudes do. That is, the higher the temperature, the less dense the air is. The wings then have almost nothing to push and produce lift from. In this case, the plane would need to move much faster to be able to get that lift it needs to take off. The problem with that is, you only have so much runway to work with. To minimize the risk of that dangerous situation happening, the plane needs more of everything than it takes in normal conditions. More engine power, more thrust, larger wings, more speed, and a longer runway. Because the plane's climb performance is so much lower, it can only lift a smaller number of passengers and cargo. The temperature outside, airport elevation, and runway length are the 3 factors that affect how reduced this amount will be. For some planes, mostly smaller ones, it gets to the point where it not only has to be reduced, but the flight must be rescheduled because it would be too dangerous for it to even try to take off. Lower air density is the main problem in extremely hot weather. But it's not the only one. Aircraft components like onboard electronics overheat. Seals can get too soft or melt. Brake temperatures increase during landings. There can be cabin cooling issues. A lot of things can break down in crazy hot temperatures. And don't forget that it takes people to service the aircraft and the airport. Many of them work outside, and the heat affects them directly, making working conditions unbearable. Phoenix Sky Harbor is, of course, not the only airport where high temperatures have messed up the schedule and passengers' plans. In 2013, during a heat wave in the UK, Many travelers had to be bumped from their booked flights to make the plane's burdens easier. It happened at London City Airport, where the runways are shorter than at other nearby airports. Leaving a few passengers on the ground is one of the possible solutions when the plane just has to take off, no matter how hot it is. Reducing cargo or flying with a less than full fuel tank – they can always refuel somewhere cooler later – are other possible options. In some places around the world, the heat isn't a temporary inconvenience, but a permanent situation people have to work with. The Middle East, for example, is home to one of the most important transportation hubs in the world – Dubai International Airport. Many flights going to and from this and other Gulf airports are scheduled for night and early morning, when it gets somewhat cooler. Local carriers also normally work with larger planes that can withstand the high temperatures. It's now clear why some aircraft can't take off in crazy heat. But what about the cold? Is there such a thing as too cold to fly? Well, if anything, aircraft prefer when it's chilly. After all, they're designed to cruise at 35,000 feet, and such altitudes are known for their teeth-chattering temperatures of around minus 60 degrees. So technically, extreme cold isn't an issue in the air, but it can make the ground preparation for the flight longer and more complicated. You have to de-ice the runway and even the plane itself. And when it passes the point of too cold for aviation, the refueling equipment can just freeze. Looks like airplanes have their limits too. Hey, that reminds me. Do you prefer the cold, the heat, or somewhere in between? Let me know down in the comments. Anyway, as we continue to explore the limitations of aviation nowadays, I can't help but wonder if it can ever be too windy to fly. Going through a storm can be a scary experience for passengers, but is it really as dangerous as it seems? Well, it depends. A plane is unlikely to start wigging out just because it's going through some turbulence. Aviation engineers and manufacturers test their aircraft and specify limits for the ground, air, and cross speeds. That way, pilots know exactly how they should move in different weather conditions. However, the most critical and possibly unpredictable moments during gales are takeoffs and landings. At some airports, the winds are quite severe all year round, so landing can get too wobbly for comfort. It's risky alright, and it requires a real pro of a pilot to land during a wing strike. That's when the wing hits the runway. It can happen when the wind unexpectedly changes speed and direction, something that's called a wind shear, and a pilot must know what they're doing to land when a headwind turns into a tailwind, for example. A lot depends on a pilot's skills when it seems to be too wet to fly as well. Heavy rain is mostly a problem when it comes to landing. Runways are designed in such a way so that water doesn't remain standing on them. However, if that happens, pilots have to adjust landing speed and distance, depending on how much water is on the ground. Hydroplaning is the riskiest situation that can happen in wet weather. You see, if enough water gets between the plane's tire and the runway, it'll reduce the friction needed there to bring the aircraft to a stop. Then the pilot has to deal with skidding. If you thought it's difficult enough in your car, imagine losing control of a jumbo jet. Fortunately, such cases are rare. And who knows? Maybe in the future, airplanes will be able to safely take off, fly, and land in extreme heat, cold, wind, and rain. Granted, we still have to bow down to the laws of physics, but I'm sure aviation engineers are hard at work making improvements and innovations. I'm still waiting for teleportation to come around, so that I don't have to deal with another canceled or delayed flight ever again. For now, I'll just keep dreaming. Hey, if you learned something new today, then give the video a like and share it with a friend. And here are some other cool videos I think you'll enjoy. Just click to the left or right, and remember, stay on the bright side of life.